Hey everybody, this is Dark Guardsman, and we're back with another video. So, I wanted to go over really quickly something I've been working on in kind of the background to kind of debug and test things. So as some of you may have known from, or seen from other videos, I like to make applications to help kind of diagnose and test data outside of Minecraft in a way that's easier to understand. We do this through the JSON data system where we can track all of our JSON systems, all of the missiles, everything. We can pretty much go through the whole entire process. Look at all these, reload them, and see a list of everything. We do the same thing for recipes. We basically can see every furnace recipe and so on and so on. So one of the applications I just developed was a way to test and kind of visualize how the missile flight code works. Now we already have a device in ICBM Classic that kind of does this. It's the little computer thing. Let me go ahead and pull this out. I just call it the computer. I think it has an actual name, but the reality is it's so underused that even I don't know what it really is called anymore. It's called the Missile Coordinator, so go ahead and drop down here. I've been kind of testing missiles in this world, although you don't really see any craters here, but that's what we've been kind of doing. So what this literally lets you do is it lets you kind of calculate the flight path between 2 points, so that way you can go and figure out roughly how your missile flight trajectory is going to work. Say we were launching our missile from here and we wanted to hit over there. What we can literally do is come in here and place these in here, and as soon as both those in here, it'll actually calculate some math for us. It'll tell us, okay, here's how many meters the missile is going to travel flat distance if you didn't include the arc upwards. Here's the actual distance including the arc. Here's the amount of time in seconds it's going to do, and it'll even give you a direction with meters. So it'll go like, hey, this is 182 meters north from where we're currently at. So it'll do some basic math, but this doesn't really tell you much, especially for me as a developer. When I'm launching these missiles, I really can't, unless I ride the missile, see how it's going to arc through the air and land. What makes this even worse is that when Calculabi wrote this code, he didn't really document it well, and I've been coming through here and I've been documenting the living snot out of it to kind of understand what's going on. And there's a lot of magic numbers in here, which makes it even worse. So these numbers like 160, 3 to 100, and so on are not really documented. I can get a rough idea of what they do. For example, I know the 3 will scale pretty much the max height, but at the same time we defaulted 160. So I'm going to assume this is kind of the minimum height the missile will travel in order to prevent it from hitting terrain or whatever else. Apparently at some point in time it was decided 160 is a good number. With that as well, there's a flight time thing that also says, okay, 100 is going to be the minimum flight time in order to make this math work. And there's a lot of other math going on in here that isn't really explained at all. And when I got the original code, back when I was working on Calculabi with it, nothing was documented. The only reason there's even documents in here to start with is because that's what I've put in there as I've worked over time. But so far, we kind of have a rough understanding of what's going on. So very first thing, and I'm going to go over and explain how this works. When you go to launch a missile, it's going to store 2 positions, and it stores this at the top somewhere here. So it stores the target and launch position. So when you launch it, it's going to store where it launched from, it's going to store where it's attacking, unless you launch it from a rocket launcher, and then it's a little different story. When it does that, when you actually call the launch code on it, which is done somewhere down at the bottom here, it will actually calculate the displacement, so what distance is going to travel in the X, Y, and Z to get there. It's then going to calculate a flat distance. This is what it's going to travel in the X and Z direction to get there. It's going to figure out whatever height it's going to go to. This is the height it should max out at. Does not mean this will be the height it actually travels to, it just means this is where it's supposed to limit itself at, but that's not actually how the code works. We then get a flight time where it kind of tries to figure out, based on the flat distance, how much time it should take. Now this is of course based on the flat distance, so hence why it's got a 2 scale here, and it's kind of a little funky. And this is where I'm hopefully by the time I debug and figure out and visualize all this data, I can reverse engineer this math enough that I can come through here and clean this up. Because there's a lot of problems with these math functions. One, as you actually fire further away, the missile actually will travel faster. And this is something I really don't want to happen. I want it to kind of travel at a very consistent speed. Not really a consistent speed like saying it goes 30 miles an hour at all times, but like a consistent acceleration that goes okay until it gets to the maximum Y. It's going to consistently accelerate by 10 meters a second or 10 meters a tick or something like that. So that way there's a predictable speed and the time is pretty much predictable. Because with this, you get pretty much a linear time frame, and you're not really supposed to have a linear time frame of the missile. It's supposed to kind of be exponential, where the further the distance you get away, the longer and longer it takes to travel, or some kind of, I guess it could be linear, it doesn't really matter. We also get acceleration here. These numbers, it can skyrocket throughout the roof really quickly, and of course we still have magic numbers here. So we have a magic number for that, we have a magic number for this, and I want to get these figured out. That way what we can end up coming through here later is add a config both to the 1.7 version, because I'm working on the 1.7 version right now, and the 1.12 version, and actually add speed controls to this. So that way, as a mod pack developer or user, you can come in and go, hey, here's how fast I want this missile to travel at all times. Or here's how fast I want it to scale. So that way you can scale this and actually control the missile flight time, which is a really big thing I want to be able to do. So you can go, okay, I want missiles to travel 10 times slower, 10 times faster, and so on and so on. But we got this block. This basically does the preliminary calculations to figure out what the data is going to give us. So as long as you have a start position and end position, it'll calculate all this data, but it doesn't give us what we really need. The next part about this is ended up getting calculated somewhere down the launch code down here somewhere, if we can find it real quick. Have to scroll a little bit. Actually, we're going to cheat and we're just going to type in the word launch. And at some point we should actually get our method. Do this real quick. Here we go, get the launch. So when you actually call launch, it'll actually do a few things, and it actually does update the motion. So I guess I was in the right spot to start with, but I'm a little sleep deprived, so I'm kind of a little lost in my own code. So when we end up actually calling launch and we update the motion, so it updates the motion the first time, first thing it's actually going to do is make sure that the missile goes straight up. There's a lock height set, by default it's 3, so it's going to go up 3 meters before it starts to curve, and of course you can set this as much as you want. There's actually a GUI in the game that actually does allow you to control this, so that way if you have a missile silo, you can actually set this lock height to 30 and it'll go up 30 meters before it starts to curve, which is really useful when you actually want to do things. As soon as it gets to that max distance, it's actually going to set the motion. So this is when the first time it actually ends up calculating the actual trajectory of the missile. And this is what it really does most of the work right here. So from the acceleration and flight time, we calculate the Y motion. This is what it's going to end up going straight up. And then we calculate the X and the Z. This is what's going to aim us towards the target. So X and Z are our aiming trajectory, and this is actually our motion trajectory. Once this gets set, then it's basically going to go into a loop where it's going to, every time it updates, it's going to call update motion again, which is then going to come down to this part, which is then going to decrease the motion by our acceleration. So we actually do slow down as we go. In which this case we start off, basically when you do this, we're at max acceleration right off the back. This is something when I want to reverse engineer the equation, that way we have a ramp up time for the acceleration rather than having an instantaneous burst of speed. Instantaneous burst of speed is kind of good for a cannon function. It's the reason why I explain to a lot of people when they ask how the missiles work. They are a lot closer to how arrows work. Because an arrow is going to pretty much be at its max speed as soon as it leaves the bow, and in this case the missile is no different. It's at its max speed as soon as it leaves the launcher. And of course we decrease the motion and we just recalculate our trajectory. So this is all cool and all the math works, and it's kind of easy to understand what the math actually does, short of a few things like why are we doing the missile flight time and so on, why does this data exist and what does it actually do and so on and so on. But you can understand where it's kind of heading to. You end up with basically a vector at the end that tells the missile, hey, I need to fire off in that direction or something like that. But this doesn't actually tell us anything we want to know. So if we want to come down through here and we want to say, okay, maybe I want to modify this to be 260. What does that actually do to the math? Maybe I want to modify this to be 4 times, 5 times. What does that actually do to the math? You can't really tell what it's doing without simply riding the missile to the target. If you have to repeatedly do that all day long, you're going to get bored rather quickly, and it's going to take forever. So instead of doing it that way, what I've ended up actually doing is building a little simple Java application. This is the entire application. Very simple, uses Java AWT, which is a very old rendering system that's built into Java. It's been there since I think Java 2. And so it's really, really old. I probably should switch this to like Java FX or something, which is a much more modern system. But it does the job. So what I can do is I can right click and hit run here. And this will actually visually show what is going on right now. And of course it will even print data up. So I can see exactly what the flight path would look. And of course this is 2D. The reason it's 2D is because there is no real difference between the 2D and 3D path except for the inclusion of calculating the Z coordinate. And the Z coordinate would just kind of shift this. Think of it like aiming something left or right. That's what this would end up being. So in this case we're just kind of figuring out where we're going to go in the Y and where we're going to go in the X. And it gives us a really good indication. Of course I can stretch this too so I can actually look at it, and it's cool. I can sit here and look at this, and more importantly I can come over here and look at the data. And the data will tell me everything I need to know. So when I input this, and for example this equation, what it's doing actually right now is calculating a start and end point to 0 to 200. And more than likely when I work on this tool more, I'm going to end up actually adding a couple buttons on the side of this and text boxes so I can actually modify this data in real time without having to relaunch it every single time. But for the moment it works. So we got the data, tells me I'm going to go from 0 to 200, tells me exact distance, which is 200, tells me the height I'm going to go to, tells me the amount of time and ticks it's going to take, and tells me the amount of starting acceleration we're going to actually get. which is a little bit low actually, but I'm still working on making sure the math is 100%. It'll then give me the starting motion vector, which tells me right now I'm going to go 2 meters a second, or 2 meters a tick in the y. It'll then tell me the position. So for t1 tick, so for the first tick, I'm going to be at the starting position. I'm not going to go anywhere, but I have my motion set, 0.5 and 1.9, and this is going to slowly go through. Of course, we're seeing that the y is decreasing, and the y will continue to basically decrease until it goes negative, which is basically gravity taking over, or that's what it's supposed to do. More than likely, what I end up actually doing is modifying these missiles so that way gravity is actually the acceleration once you get past the maximum point, and it'll behave a lot more like a projectile, a lot more like an actual missile does in real life. So ICBMs in real life, when they actually, unless they're specially modified to do something different, there's a few Russian variants and stuff, and even American variants that will fire their engines after they go down the deceleration path to gain even more speed. But a conventional ICBM will accelerate upwards, and then when it gets to the top of the parabola, so this is what a parabola is, so when it gets to this point right up here, it will pretty much have stopped accelerating. Usually how it actually works is it goes up to this point, then you usually have the first booster stage, it goes up the next thing, second booster stage, you go to the next point, third booster stage, and at this point there's no fuel left, and you're pretty much riding the arc. You get up to this point, you're not really going up anymore, and then gravity is what's taking you down the rest of the way. And because you're in orbit, pretty much, you have multiple kilometers to accelerate back down, you end up going pretty much multiple times the speed of sound by the time you hit the ground down here. This is pretty much the same idea, because by the time you hit the ground, we're going about -2 meters a second, which if we actually did the math here, so we say 2 meters, actually 2 meters a tick, so there's 20 ticks a second, so that's 40 meters a second times 60, so we're doing 2,000 a minute, times 60 again, so we're doing 144 kilometers an hour, which is roughly about 90 miles an hour. If I'm doing my math correct, we can actually check Google for this one. Let me go pull this page over here, km to miles per hour. I think the speed of sound is like, so that's 144, so yeah, 90. I was really, really close, and I didn't prepare that. And let's do the speed of sound. So the speed of sound is 340 meters per second, which, if we go back to our math, we were, what, 2 times 20, so that's the 40. Yeah, so we're going, actually, we're not even going that fast. I guess we can go a lot faster. But needless to say, you'd probably be going the speed of sound by the time you hit the ground. There's actually a constant that prevents you from going faster than a certain amount. I forget what it's actually called, but needless to say, that's what we're getting is this data, and this is actually allowing us to visualize it, see what's going on, and what I can come down through and do is I can start modifying information. So for example, if we wanted to say our default height was 460, I can go and close this, and I can run it again. The visual data isn't really going to change much because there's actually some scaling factors going on to make sure this fits on my screen when I load it up. But what it'll do is it'll change how the acceleration looks. So now we're almost at 3 meters a second by the time we hit the ground. We should still hit the same target, so 200x, and we still hit the same Y level, which is basically 0. This is actually set up to stop calculating by the time it's 0, so that's your detonation point. Still travel in the same exact amount of time. So changing our max height doesn't actually change the amount of time it takes to get there. What this will effectively do is actually make sure the missile goes to a certain height before it starts falling again, which is really useful for mod pack makers that may decide to install a mod like Cubic Chunk that it makes the world infinite. They may decide, okay, there's a certain point when we don't expect people to build mountains or have mountains generate. We want the missile to make sure it goes over that amount of height, so that way it doesn't smack into the side of a mountain and blow up. Although that would be kind of a cool feature that you would have to plan around your strategy to make sure your missile didn't impact a mountain. But you can see, go back to the data. Actually, data. Goes to run category. So, but we can come through here, we can look at this, and we can actually check what our Y level is. At some point around 200 should be our middle point. And we can actually sit here and look and say, okay, we went to 266Y. So we know from testing this now that this actual max height has almost nothing to do with the actual Y level we will achieve when we do that. So there's actually some values here. So that 160 may have absolutely nothing to do with our actual max height value, and instead this variable may have something completely different to do. This may be a scalar modifier just for acceleration, because the only time you actually see this being used is down in acceleration. So this could be a velocity calculator, because we got our flat distance and so on and so on. But anyways, that's the video. I just kind of wanted to show off this stuff, and this is some of the stuff we're working on in the background to kind of reverse engineer a lot of the old code, because even though I worked on the mod with Calclavia, it didn't leave me with any notes when I actually ended up getting the mod from him. So there's a lot of code we still have to go through, clean up, and eventually reverse engineer and get perfect. And when we get to that point, we'll be able to do a lot more cool stuff with this code. And so hopefully when I get it reverse engineered, I'll be able to take this over to the rewrite of ICBM, and maybe even other mods, like we might be able to do artillery cannons with the same exact math and do some really amazing things with it. But I'll leave you guys there, and I'll see you guys later with another video.